Lesson 1, Properties of Quadratic Functions. So a quadratic function is a function that can be written as ax squared plus bx plus c. And what it means is that it's going to have a degree of 2. So it's going to have a variable raised to the power of 2. And a quadratic function will make a parabola. So this is a parabola, this shape. A parabola has a vertex, and the vertex is either the very minimum or the very maximum point. So this one is the very minimum. And we label our vertex P, Q. So P would be your x value, Q is your y value. This dashed line is the axis of symmetry. And what that means is that on either side of the axis, it's identical on both sides. So if you were to fold this quadratic in half, it would lie directly on top of each other. And our axis of symmetry is equal to x equals p. This quadratic opens up. And because of that, we know it has a positive a. And we'll come back to that a little bit further on. But just write it in your notes so you have it. So this one is different. It's a maximum vertex at P, Q. We still have an axis of symmetry at x equals p. This time it opens down, so we have a negative a. And remember that this is your vertex. I didn't label that. Vertex. Okay, graphing quadratics. First thing is finding your vertex. So what you want to do is you want to find two x values that have the same y. So right here, this x value has the same y. So that means that if you were to graph it, that the shape will come up to the vertex around this point. So we're going to graph all the points so that we can see this. So let's go up by, every 2 could be 0.25. Just one second, I'm going to make it bigger. So every 2 will be 0.25. So this would be 0.75, this would be 1. 1.25, 1.5. And going up, we can go up by 1s. So 1, 2, 3, 4, 5, 6, 7, 8. So we're going to plot 0 is 2, 0.25 is 6, 0.5 is 8, 0.75 is 8, 1 is 6, and 1.25 is 2. So what you can notice is you can kind of see where the axis of symmetry is. It reflects down. So at this point, it starts to go back down. So to find the vertex, you're going to choose 2 points that have the same y. So 2 x points, and you're going to find the middle of them. So add them together and divide by 2. It can be any 2. You could use the 6 and the 6 or the 2 and the 2. It doesn't matter. You'll get the same thing. So you just want to find halfway between them because the axis of symmetry is always exactly between those 2 points. So we find that x is equal to 0.625. So we go to 0.625, which is directly in the middle here, draw in our axis of symmetry. And if we were to guess about how high this point comes up, it looks like it's about 8.2. So our vertex, judging by our graph, is 0.625, 8.2. And that's not precise, it's approximately 8.2. So you would draw your graph through those points. So there's your parabola. So we want to find our domain and range from this. So always remember that your domain is your x's and your range is your y's. So for domain, we go dx such that, now if we were to keep continuing this parabola on and on, it would go forever and ever down. So x would actually end up going on and on forever. So x is an element of the real number set. Now we have maximum and minimum y's. So x can go forever, but because this parabola opens down, we have a maximum value of y. So there's a maximum at 8.2. So for our range, we know that everything has to be smaller than 8.2. So y such that y is less than or equal to 8.2. So that is how you find your range for this parabola. And our axis of symmetry is the x value of our vertex. So x is equal to 0.625. So for our next example, we need to find our vertex and graph everything. So we have two x values here. So we have -1 plus 0 divided by 2. So x is going to equal -0.5. So our vertex and our axis of symmetry is x equals -0.5. So let's start graphing. So let's say every two spaces is 1. One, two, three. And we'll go up by 1. So our axis of symmetry, we know, is at -0.5. And we're going to plot all of our points. So -3 is at 4. -2 is at 0. -1 is at -2. 0 is at -2. 1 is at 0. 2 is at 4. So it looks like our vertex goes to about probably somewhere in there. So here's our parabola. That looks really bad. Be as careful as you can when you do it on your paper. As long as you go through the points that you're showing, that's most important. So it looks like our vertex is -0.5 and -2.2. Somewhere in there. 2.5, 2.4. So this time it opens up. So we have a minimum of y equals -2.2. Our domain is x such that x is an element of the real number set. And our range is x such that we want y to be bigger, so greater than -2.2 or equal to. So there's our domain, range, vertex, axis of symmetry, and it opens up.